Hello everyone, in this video we are following chapter F4.0 Filter Map Reduce from the book Cloud-Based Remote Sensing with Google Earth Engine. In this chapter we learn the three important concepts: filter, map, and reduce. These concepts are required to build our knowledge in using Earth Engine. And this chapter also shares an analogy about shopping for milk, and this is well explained in the chapter to understand these three concepts. So we have the filter, map, and reduce. Filter selects the subsets of images based upon the criteria of interest. So we have a large number of image collection here, and after filtering, we have lesser number of image collections. Then we do the map. This is to manipulate each image in such a way that we have some goals to get some images or to do some processes. And then we do the reduce, and this estimate the characteristics from the time series. So we will try to go through the codes. These codes are not that difficult, so it is understandable even for the beginners. So we have the image collection here. This is Landsat 5, and Landsat 5 image collection has been assigned to this variable img_col, and every dataset in Earth Engine has this unique ID, and this is the unique ID for this Landsat 5. And if we see the size of this Landsat 5, we do this by dot size, and this is giving us some number, and that is very large in itself. And we want to filter that by some dates. In a simple way, we want to find images between those dates. So we do that by dot filter date. Earth Engine has different ways to filter, and dot filter date is one of them. So we provide the start date and end date, and now we can see that the images here, the size of the images or the image collection has reduced. Then we want to find the images that is present in the Shanghai area. So in this case, we had this image before, and we just wanted to center in the map with the zoom level 9. And from that, we want to filter bounds. That means we want to have the images from that area. So basically, we took the image that was the Shanghai image, and then we centered that image. We are not displaying it, we're just centering it into the map, and we do the filter bounds from that centered area, that is Shanghai. So basically, we are getting the images from the Shanghai area. And we do this dot filter bounds, then we do this map dot get center, and this time we get very less number, that is 125. We continue this process, and we also want to have some check some cloud presence, and this cloud underscore cover is different for different satellite data. For Landsat 5, we know that this is cloud underscore cover, and we want to find the images that will have the presence of cloud to be less than 50%, and that will be only for the images present within the 2000 to 2010. And this time we get the image collection size to be less than the image size to be 83. So basically, we are reducing the criteria, reducing the size of the image collection based upon the criteria. Then we continue further. Here we have these filter bounds as well as the cloud cover less than 50. So again, this time we are getting the same number, so it is 83 again. And then we are continuing this process with filter bounds. Then we do the filter depth and we do this filter metadata. And the number is constant in this case. If we change this number, or if we play it with this start date and index, then we can alter this number and we get the different size of the image collection. So this is basically the way to filter the images. And if we want, in the Documents tab, there are other ways to filter the images. So the main idea is to reduce the image size, but the main thing here is to suit upon our interest. So if we are working with our own area of interest, then this comes very handy to select the images that are only within our area of interest. Then we have the second set of codes here, where we do this mapping function, and map has different meaning here. The chapter very nicely explains this. So the first one is the map. This is the map panel where we can scroll, hover over different area, or we can play with the mouse and look at different area. That is the first map, or the map panel. And the other map is the earthengine object. So map dot something contains the object or the function. So there can be map.add layer is one of them. But in this case, map also refers to the set of actions that can be applied to the image collection. So here, what we do is we create one function, and that function is mapped to the image collection. So we do not need to write that codes for each image collection. So this is to make the code more efficient. And in other programming languages, we have this loop function, and earthengine does not suggest the users to use loop functions. So rather we use this dot map. So in this case, we have this make Landsat EVI function. And in this function, we take the very fast Landsat 5 image, and then we are selecting different bands. We are dividing with some constants. So this is to extract the bands, and dividing with these numbers to account for scaling. So we are doing some scaling process. Then we are calculating, trying to calculate the EVI. So we are subtracting, or we are simply doing NIR minus a rate, and then multiplying with by 2.5. And then we're also multiplying this red band with 6 and blue band with 7.5. And we're doing this NIR plus this denominator, subtract denominator. So it seems to be confusing. It might be, but it is nothing, just in applying the formula of EVI. If we search the formula of EVI, we're just applying that formula in the text format. And basically the function also needs to return the final image. So in this case, this is the variable name, and this whole function is applicable to the Landsat 5, because the band names may be different in other Landsat satellites or other Landsat data. And then here we are mapping this by dot map, and this is the function here. So what it does is it is going to select every image collection, then we'll select the images and do this for each image there. So this is quite efficient for that. And then again, we can do the size, check the size here. This time it says it's the verifying that the map keeps back the same number of images. And if we check this images, we can see here we have the features, and we are only getting one band, and that band is EVI. So we get the EVI bands in all the features, so they are being written as the features. And then we also have this map.addLayer. So this was the earthengine object I was talking before. So this map.addLayer adds this image to this map panel. And if we can see this, so map.addLayer has this different parameters here. The first one is the name of the image. The second one is the visualization parameter. And this third one is the name. So this is the string that will appear here. So this is the same. And the sun means one here means when we run this will automatically be ticked, or this will automatically be added. So this will be always be ticked. If we set as 0, this won't be ticked. So this is just to change the default here. And this opacity means this will be totally opaque. So this is the scroll here. We can make it transparent. And this is useful when we see the, when we do some kind of change detection. Then we move to the final set of codes. So here we are being made aware with this dot reduce. So here we are using this image collection by dot reduce, and we are applying this reducer ee.reducer.mean. And then we are printing this. And if we see this, this is only one band. So this is EVI mean. And then we also have this median reducer that is done by ee.reducer.median. So we are doing dot reduce, and inside this dot reduce, we are providing this this reducer. And then we are again printing this. This also gives us a single image or single band here. That is EVI median. There are other types of reducer. One is the min-max reducer, which gives us the two-band image. And we can see this here. We have this black and white image because we didn't provide it. We didn't provide this anything here. So inside this, we provide the visualization parameter. So we didn't have, we do not have any colors in this. But in this case, we can see that map.addLayer contains some color in the palettes. We have the minimum and maximum values to this image, which is being provided in this curly brackets. And we get these colorful images this time. The first one is the mean EVI. And this is the mean EVI. And we can see the difference that median EVI is much more beautiful because it just neglects the extreme values. It's running here. So median basically excludes the extreme values. So it is more nicer to see this here. So these three are the very important, very necessary concept in earthengine. So we are following chapter F4.0. We're also exploring some of the chapters that are very bulkier and very difficult. But I hope this was helpful. I hope this was helpful to you. Please comment if you like. Please subscribe if you haven't. Thank you for watching.